Hello children, today we will solve few questions from previous year's JEE papers. The one and only one trick to solve these questions like a pro is to keep the various terms definitions in your mind. For example, what is mole fraction, molarity, molality, ppm, limiting reagent, molecular formula, empirical formula, etc. So let us start. First question, in an estimation of bromine by Carrier's method, 1.6 gram of an organic compound gave 1.88 gram of AgBr. The mass percentage of bromine in the compound is atomic mass of Ag is 108 and that of bromine is 80 gram per mole. This question appeared in JEE Mains 2020. Suppose X is organic compound. 1.6 gram of X gave 1.88 gram of AgBr. First, we will calculate the molar mass of AgBr. 1 mole of AgBr consists of 1 atom of Ag and 1 atom of Br. So, molar mass will be 108 into 1 plus 80 into 1. That is 188 gram. So, out of 188 gram of AgBr, bromine is 80 gram. So, out of 1.88 gram of AgBr, how much will be the bromine? That will be 0.8 gram. This bromine is coming from X. So 1.6 gram of X contains 0.8 gram of bromine. So 100 gram of X contains how much of bromine? It will come out to be 50. That means mass percentage of bromine in X is 50%. So we will fill 50 here. Second question, the minimum number of moles of O2 required for complete combustion of 1 mole of propane C3H8 and 2 moles of butane C4H10 is. This question appeared in JEE Mains 2020. Combustion means reaction with oxygen. First step is to find out the balanced chemical equation. That comes out to be 2C3H8 plus 10O2 makes 6CO2 plus 8H2O. And 2C4H10 plus 13O2 makes 8CO2 plus 10H2O. Now 2 moles of C3H8 react with 10 moles of O2. We have to find out 1 mole of C3H8 will react with how many moles of O2. So it will be 5 moles of O2. 2 moles of C4H10 reacts with 13 moles of O2. And we have to find out the same 2 moles of butane. So it will be 13 moles of O2. So combining these two, we need minimum number of moles of O2 required will be 5 plus 13. That will be 18. So answer is 18. Third question, complete combustion of 750 gram of an organic compound provides 420 gram of CO2 and 210 gram of H2O. The percentage composition of carbon and hydrogen in organic compound is 15.3 and respectively. Round off to the nearest integer. This question appeared in JEE Mains 2021. Suppose X is organic compound. Combustion means reaction with oxygen. So 750 gram of X gives 420 gram of CO2 and 210 gram of water. First, we will calculate the molar mass of carbon dioxide. So it will be 12 into 1 plus 16 into 2. That will be 44. Similarly, molar mass of H2O will be 18. So out of 44 gram of CO2, carbon is 12 gram. So out of 420 gram, how much will be the carbon? It will be this much. Similarly, out of 18 gram of water, hydrogen is 2 gram. So out of 210 gram of water, how much is the hydrogen? This much. Now both carbon and hydrogen are coming from X. So out of 750 gram, hydrogen is this much. So out of 100, how much will be the hydrogen? It comes out to be 3.11. We have to round off to the nearest integer, so it will be 3. Our answer will be 3% of hydrogen. Fourth question, 1.86 gram of aniline completely reacts to form acetanilide. 10% of the product is lost during purification. amount of acetanilide obtained after purification in gram is something into 10 to power minus 2. This is the chemical reaction. This question appeared in JEE Mains 2021. From this chemical reaction, it is clear that 1 mole of aniline produces 1 mole of acetanilide if there is no loss of product during purification. Considering the loss during purification, 1 mole of aniline produces only 0.9 moles of acetanilide. So let us figure out how many moles of aniline were there in 1.86 gram. Molar mass of aniline we can calculate as 12 into 6 plus 1 into 5 plus 14 into 1 plus 1 into 2. That comes out to be 93 gram. So number of moles of C6H5NH2, that is aniline, will be 1.86 gram upon molar mass 93. So that comes out to be 0.02. That means initially there were 0.02 moles of aniline. So they will produce 0.02 moles of acetanilide if there is no loss of product. Considering the loss, it will be only 90% of 0.02. That comes out to be 0.018 moles of acetanilide produced. So if we multiply this number with molar mass of acetanilide, we will find the exact amount of acetanilide produced. So molar mass of acetanilide we can calculate as number of carbon atoms in this structure is 6 plus 1 7 plus 1 8. So 12 into 8 plus number of nitrogen atoms 1. So 14 into 1 plus number of oxygen atoms 1. 16 into 1 plus number of hydrogen atoms 5 plus 1 6 plus 3 9. So 1 into 9. That comes out to be 135. That is molar mass of acetanilide. So mass of 0.018 moles of acetanilide will be 0.018 into molar mass 135. So the amount of acetanilide produced will be 2.43 gram. We have to write answer into something into 10 to power minus 2. So we can rewrite this as 243 into 10 to power minus 2 gram. So we will fill 243 in the blank here. Fifth question, the NaNO3 weighed out to make 50 ml of an aqueous solution containing 70 mg Na plus per ml is dash gram. Round off to the nearest integer. Atomic mass in gram per mole, sodium 23, nitrogen 14 and oxygen 16. This question appeared in JEE Mains 2021. So we have to make the aqueous solution of NaNO3. It is given that 1 ml of this solution contains 70 mg of Na plus. So 50 ml of this solution will contain how much of Na plus? It will be 50 into 70 upon 1. That will be 3500 mg of Na plus. That is equivalent to 3.5 gram of Na plus. NaNO3 is made of Na plus and NO3 minus ions. Let us calculate the molar mass of NaNO3, and that will be 23 into 1 plus 14 into 1 plus 16 into 3. That comes out to be 85 gram. 23 gram of Na plus is there in 85 gram of NaNO3. So 3.5 gram of Na plus will be there in how much of NaNO3? It will be 3.5 into 85 upon 23. That comes out to be 12.93 gram of NaNO3. Now we have to round off to the nearest integer. It will be equal to 13 or equivalent to 13 gram of NaNO3. So we will fill 13 here. Sixth question, complete combustion of 3 gram of ethane gives x into 10 to power 22 molecules of water. The value of x is round off to the nearest integer. Use Na is equal to 6.023 into 10 to power 23. Atomic mass in U, C12, O16 and H1. This question appeared in JEE Mains 2021. Balanced chemical equation is this. 2C2H6, that is ethane, plus 7O2 makes 4CO2 plus 6H2O. It is clear from this equation that 2 moles of C2H6 produce 6 moles of water. So first let us figure out how many moles of C2H6 are there in 3 gram. So molar mass of C2H6 is 12 into 2 plus 1 into 6, that is 30 gram. So number of moles in 3 gram of C2H6 will be 3 upon 30. 3 upon 30. So that will be 0.1 moles. Now 2 moles of C2H6 produce 6 moles of water. So 0.1 moles of C2H6 will produce how many moles of water? It will be 0.1 into 6 upon 2. That is 0.3 moles of water. We know that 1 mole of water contains 6.023 into 10 to power 23 molecules of water. So 0.3 moles of water will contain how many molecules of water? That comes out to be 1.8069 into 10 to power 23. We have to write the answer as x into 10 to power 22. So we will convert it to 10 to power 22. So it will be 18.069 into 10 to power 22. Now we have to round it off to nearest integer. So it will be 18 into 10 to power 22. Now compare this with this, x comes out to be 18. That is our answer. Seventh question, this is the reaction. Consider the above reaction where 6.1 gram of benzoic acid is used to get 7.8 gram of M-bromo-benzoic acid. The percentage yield of the product is, round off to the nearest integer, given atomic mass in U C12H1O69Br80. This question appeared in JEE Mains 2021. So this is the chemical reaction given. This is benzene ring. It is represented by C6H6. Since COOH is attached with it, that means we have to take one H out. So its formula can be written as C6H5COOH. Similarly, this is benzene ring, one Br and one COH is attached. So we have to take two H out, and in place of both H, we have to write one Br and one COH. So its formula will be C6H4BrCOH. So now this will be the chemical reaction. It is clear from this chemical reaction that 1 mole of benzoic acid will produce 1 mole of M-bromo-benzoic acid. So first we will figure out how many moles are there in 6.1 gram of benzoic acid. So molar mass of C6H5COH will be 12 into 6 plus 1 into 5 plus 12 into 1 plus 16 into 2 plus 1 into 1. That will be 122 gram. So number of moles of benzoic acid will be 6.1 upon 122. That will be 1.20 or 0.05 moles. So 0.05 moles should produce 0.05 moles of M-bromo-benzoic acid. So let us calculate the molar mass of M-bromo-benzoic acid, and that will be equal to 12 into 6 plus 1 into 4 plus 80 into 1 plus 12 into 1 plus 16 into 2 plus 1 into 1, and that will come out to be 201 gram. So mass of 0.05 moles of M-bromo-benzoic acid should be 10.05 gram, and you see only 7.8 gram is produced. So we will say out of 10.05 gram, only 7.8 gram is produced. So out of 100 gram, how much will be produced? It will be 77.61, and that is percentage. Now we have to round off to the nearest integer. It will be 78%. So we will write 78 here. Eighth question, a 6.5 molar solution of KOH aqueous has a density of 1.89 gram per centimeter cube. The molarity of the solution is mole per decimeter cube. Round off to the nearest integer. Atomic mass in U K39O69H1. This question appeared in JEE Mains 2021. In solution, KOH is solute and H2O is solvent. And we know that solute plus solvent is equal to solution. So 6.5 molar means 6.5 moles of solute KOH in 1000 gram of solvent H2O. Let us figure out how much is the mass of 6.5 moles of KOH. So first we will calculate the molar mass of KOH. So molar mass of KOH will be 39 into 1 plus 16 into 1 plus 1 into 1. That is 56 gram. So mass of 6.5 moles of KOH will be 6.5 into 56. That is 364 gram. So in solution, mass of solute is 364 gram and mass of solvent is 1000 gram. So total mass of the solution means solute plus solvent will be 364 plus 1000, that is 1364 gram. So volume of the solution will be mass of solution upon density of solution. Mass of solution we have just figured out 1364 gram and density of the solution is given as 1.89 gram per centimeter cube. So volume of the solution will be 1364 upon 1.89 centimeter cube. So molarity of the solution will be given by moles of solute upon volume of solution. Moles of solute we already know 6.5 moles of KOH. Upon volume of the solution we have just figured out 1364 upon 1.89. So it will come out to be 0.0090 moles per centimeter cube. And we have to write the answer in mole per decimeter cube. Means we have to multiply this by 10 to power 3. So it will come out to be 9 moles per decimeter cube. So our answer will be 9 moles per decimeter. Ninth question, for a reaction N2 plus 3H2 makes 2NH3, identify dihydrogen H2 as a limiting reagent in the following reaction mixtures. These are the options given. This question appeared in JEE Mains 2019. It is clear from this equation that in order for H2 and N2 to get completely consumed in the reaction, the molar ratio of H2 is to N2 should be 3:1. For H2 to be limiting reagent, number of moles of N2 should be more than 1 when number of moles of H2 are 3. So let us see out of these options in which option number of moles of N2 is more than 1 when number of moles of H2 is 3. First option, moles of N2 will be 14 by 28, that is 0.5, and moles of H2 will be 4 by 2, that is 2. So N2 is to H2 will be 0.5 is to 2, that is 0.75 is to 3. So that is not the correct option because N2 should be more than 1. Second option, moles of N2 is 28 by 28, that is 1, and moles of H2 will be 6 by 2, that is 3. So N2 is to H2 will be 1 is to 3. That also is not the correct option because N2 should be more than 1. Third option, moles of N2 will be 56 by 28, that is 2, and moles of H2 will be 10 upon 2, that is 5. So N2 is to H2 is 2 is to 5 or 1.2 is to 3. So this is the correct option. Let us see option 4 also. Moles of N2 is equal to 35 by 28, that is 1.25, and moles of H2 is equal to 8 by 2, that is 4. So N2 is to H2 is 1.25 is to 4, that is 0.94 is to 3. That also is wrong option because N2 should be more than 1. So our correct option is option 3. 10th question, 6.023 into 10 to power 22 molecules are present in 10 gram of a substance X. The molarity of a solution containing 5 gram of substance X in 2 liter solution is dash into 10 to power minus 3. This question appeared in JEE Mains 2020. We will form our logic as 6.023 into 10 to power 22 molecules are present in 10 gram of substance X. So Avogadro number means 6.023 into 10 to power 23 molecules are present in what amount of substance? That comes out to be 100 gram. So 100 gram is molar mass of substance X. Now we will figure out how many moles are there in 5 gram of substance. That will be 5 upon molar mass 100, that is 1 by 20. So 1 by 20 moles are present in 2 liter of solution. So we will form our logic again as 2 liter solution contains 1 by 20 moles of X. So 1 liter solution will contain how many moles of X? That is 1 upon 20 into 2 in denominator, that is 1 by 40 or 0.025 moles per liter, or we can write as 25 into 10 to power minus 3. So in this space 25 will come. 11th question. Aluminium reacts with sulfuric acid to form aluminium sulfate and hydrogen. What is the volume of hydrogen gas in liters produced at 300 Kelvin and 1 atmospheric pressure when 5.4 gram of aluminium and 50 ml of 5 molar sulfuric acid are combined for the reaction? Use molar mass of aluminium is equal to 27 gram per mole, R is equal to 0.082 atmospheric liter per mole per Kelvin. This question was asked in JEE Advanced 2020. Balanced chemical equation will be like this. 2Al plus 3H2SO4 makes Al2SO4 thrice plus 3H2. It is given that 5.4 gram of aluminium is combining with 50 ml of 5 molar H2SO4 solution. Now we will figure out whether they are combining in 2:3 molar ratio or not. If they are combining in 2:3 molar ratio, that means they will be completely consumed in the reaction. Otherwise, one will be limiting reagent. Let us find out the number of moles of aluminium and H2SO4 first. So number of moles of aluminium will be 5.4 gram upon molar mass of aluminium, that is 27. So it will be 0.2. Number of moles of H2SO4 can be calculated as, it is given that 1000 ml of solution contains 5 moles of H2SO4. That is the meaning of 5 molar sulfuric acid. So 50 ml of solution contains how many moles of H2SO4? That comes out to be 0.25 moles of H2SO4. So the molar ratio of aluminium and H2SO4 is 0.2:0.25. Multiply both by 10. So equivalent ratio will be 2:2.5. What it means is 2 moles of aluminium need 3 moles of H2SO4 to completely combine. But only 2.5 moles of H2SO4 are available. So H2SO4 is short, means H2SO4 is limiting reagent. So our further calculation will be based on limiting reagent. Now we will say that 3 moles of H2SO4 produce 3 moles of hydrogen gas. So 0.25 moles of H2SO4 will produce 0.25 moles of H2 gas. So our N is equal to 0.25. For ideal gas, PV is equal to nRT, where N is number of moles of gas. So V is equal to nRT upon P. N is 0.25, R is given as 0.082, T is given as 300 Kelvin, and P is given as 1 atmospheric pressure. So V comes out to be 6.15 liter. That is volume of hydrogen gas produced. Last question. The mole fraction of urea in an aqueous urea solution containing 900 gram of water is 0.05. If the density of the solution is 1.2 gram per centimeter cube, the molarity of urea solution is. Molar mass of urea and water are 60 gram per mole and 18 gram per mole respectively. This question appeared in JEE Advanced 2019. In urea solution, urea is solute and water is solvent. First, we will figure out how many moles of water are there in 900 gram of water. Molar mass of water is 1 into 2 plus 16 into 1, that is 18 gram. So number of moles of water in 900 gram is 900 upon 18, that is 50 moles. So there are 50 moles of solvent water. Now mole fraction of urea is equal to number of moles of urea upon number of moles of urea plus number of moles of water. Let's say number of moles of urea is represented by Na. So mole fraction of urea is given as 0.05. So 0.05 is equal to Na upon Na plus 50. So Na comes out to be 2.5 upon 0.95. Now we will calculate the mass of these many moles of solute. So mass of 2.5 upon 0.95 moles of urea is equal to 2.5 upon 0.95 into molar mass of urea, that is given as 60 gram per mole. So mass of these many moles of urea will be 3000 upon 19 gram. Now total mass of solute plus solvent will be mass of solute plus mass of solvent, and that comes out to be 20100 upon 19 gram of solution, because solution is mass of solute plus mass of solvent. Now we will calculate volume of the solution. So volume of the solution is equal to mass of solution upon density of solution. Mass of solution is this and density is given as 1.2 gram per centimeter cube. So volume of solution is these many mLs. Now we will say when this is volume of the solution, these many mLs, number of moles of solute are these many. So if solution is 1000 ml, then how many moles of solute will be there? This comes out to be 2.99 moles, and the solution is now 2.99 molar solution. In next video, we will start second chapter, that is structure of atom. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.